Good afternoon, everyone. Today is September 4th, 2025, and you're here at the latest episode of the Mastering Enterprise Networking. I'm your host today, Jeff Gelino, and today we have some awesome guests with us from the Red Hat Ansible team, and we're going to have a very automation first session today. And automation with Cisco and Ansible, it's truly a cloud collaboration here, and we're really excited to kind of walk you through some of the latest developments as well as integrations that we've been working on. So a few things like housekeeping about the event today. First off, there is a chat as well as a Q&A built into WebEx. If you have any questions, our panelists would happily answer within the Q&A space. Please do use the Q&A as it's threaded, and it allows us to efficiently answer your questions as they come in. Also, we are recording this session today. This is a live session, and we will provide the recording to all of the attendees that are out there. So thank you all so much for joining. And again, our special guest today from Red Hat and from Cisco. So from the Cisco side, we have Craig Egan. Craig is a platform specialist and a bit of an API guru. And then from the Red Hat team, we have Daphne Mendoza. Daphne is a principal product manager and is going to also assist with our demos here today. So again, I don't want to take up any more of your time. I want to leave this full hour for the smart people, but everyone do stick around to the end. We do have some special announcements and a quiz show, and we're going to be giving away some prizes. So make sure you stay to the end of the session. And with that, I want to hand it off to you, Craig. You out there, man?
Yes, thank you, Jeff. So like Jeff said, we don't have a lot of time, so I kind of want to just jump right into things. This is the agenda for today. We're going to just kind of level set quickly on where we're at with network automation, kind of the state of adoption that we're seeing out there. And then I want to jump into a crash course to get you guys up to speed as quickly as possible, to give you the confidence to start going out there, building your own Ansible playbooks and testing these things and building infrastructure automation. Then after that, we're going to hand it off to Daphne. Daphne's going to talk about the Ansible automation platform, and then she also has a demo for you guys using that tool. So where are we at today? This is a quote from Gartner from a few years ago where they predicted by 2025, we would be at 70% implementing infrastructure automation. And talking to my customers out there, I know we're not at that number. Almost, I'd say 100% of customers have some kind of automation project or goal, but adoption has been a real struggle still. And that's why we're doing these sessions, to try to give you guys the resources and tools to actually go and start implementing these things. So why are we talking about automation still? We've been talking about it for years. Everyone knows logging into switches over SSH and configuring them manually just is not working. It's not scalable, it's configuration prone. We all know automation solves this, right? We need to be able to scale consistent configuration. One of the solutions that we've come up here at Cisco to help you guys managing configuration on your devices are our management platforms. We have the dashboard for cloud managed devices. We have Catalyst Center for on-prem managed devices. And those platforms really do go a long way in simplifying, the management operations of that infrastructure. But, it's not the end all be all, right? There's still a lot of manual clicking around. There's still errors that can be made. If we want consistency at scale, we still need some kind of automation, right? We're going to focus on the Meraki platform today for this call. But the same can be said with a lot of our other management platforms. We have a great built-in, capabilities on those platforms, but to really get the most value and scale and automate, we have to look at the APIs. Now, when it comes to our ecosystem, there's kind of two approaches to how you can consume those APIs. You can either DIY it, build your own solutions, or you can look at a partner that might have already built something and done all the hard development work for you, right? So it's really up to you guys how you want to be able to leverage and consume those APIs, either build it or buy it. Recently, we've expanded the scope of what used to be the Meraki marketplace Now it's the Cisco networking marketplace. So we're continuing to grow and build, solutions with our ecosystem partners like Red Hat to leverage not just the dashboard, but the entire breadth of our networking portfolio. So definitely go check that out. A lot of really cool solutions out there. Also, if you take away nothing from this call, developer.cisco.com. Developer.cisco.com is your one-stop shop for not just API documentation, but also learning labs, that you can go through self-paced and try out some of these things, but also code that we can share and exchange. So you can look at example code and you don't have to start from a blank sheet of paper, which I find to be really helpful. So I put this slide in here because I'm such a firm believer in the value of the open API specification. So all of our solutions are built on this foundation that is the open API spec, right? That foundational API spec that's standards-based by a governing body outside of Cisco, that is what informs and builds not only our Python and Go SDKs, if you want to do something directly in Python without having an abstraction layer on top of that. But then those SDKs actually are what are used to build the orchestration tools like Ansible and Terraform. And because we're building off of the same open API spec, we can really quickly iterate as new APIs become available, as changes are made to the API specification. It doesn't take a manual integration to go and enter those things into the Python and Ansible environments. They can be generated off of the API spec itself. So it's super, super important. As we're talking about these kind of abstraction tools, a lot of people think that, hey, I don't need to be a developer. I don't need to be a coder. I don't have to understand the APIs to be able to consume those things in Ansible. And that is true. But what we'll see today and what I want to show you guys is it actually is hugely beneficial for you to have a kind of a base level understanding of how the API actually works. And we'll see that in a demo here shortly. So hopefully everyone on the call is already familiar with Ansible. You've heard of it, maybe you've played with it. I just want to take a couple of minutes to level set here about what it is. Ansible is actually based in Python. It is written in Python, and it was first developed as a tool for helping to manage Linux server configuration at scale, right? Everyone probably has a ton of Linux VMs doing various things, web servers, database servers, etc. Ansible was developed to help scale consistent configuration for those. And then as network guys found out about it, and we're like, hey, this is really cool. We like consistent configuration at scale. Let's start adopting this for network infrastructure automation. Just to kind of level set on the glossary of terms too that we'll be using here. If you guys are familiar with Python and you've probably used a Python module or something like that that you've downloaded from pip, a collection is a similar kind of construct. It's a pre-packaged set of playbooks and modules and roles and things that you can leverage to integrate Ansible into some other environment, a different vendor solution, like a Cisco product or Meraki. We don't really use roles in this demo I'm going to show today, but roles are a reusable group of tasks that you can associate to a device in your inventory. What we'll be focusing on today are the playbooks themselves. So the actual file that contains all of the automation you want to run. A playbook can consist of one or many plays where we're targeting different infrastructure hosts or inventory objects for that automation. And then each play can contain one or several tasks, the specific bits of automation that you want to run. And the kind of glue that bridges the gap from your Ansible playbook to whatever you're targeting for your automation is the module itself. That module is basically what is translating your Ansible file to whatever protocol that you want to communicate with the device that you're talking to. For Meraki dashboard, it's going to translate that into an API call and build that API for you. For something like a switch that you might be managing autonomously, it would translate that to CLI and connect to it over SSH. We'll get more into this in the demo, but I just wanted this in the deck to give you guys the kind of anatomy of a playbook, how things are structured. All Ansible playbooks are written in what's called YAML. And the benefit of YAML is it's very human readable, right? You can see here these kind of key value pairs where we'll define something and then give it a value, right? So it's a key that is name, that's the name of the playbook. The name that we're going to call it is configure firewall policies. And this kind of YAML structure exists throughout all of Ansible. And then what you see following that here with the various tasks, task define what module to use, and then all the configuration data that you're invoking lives under that. And then the syntax you see here with the double curly braces, that is a variable. So it's referencing a variable that can change. And we're going to dive into that in the demo, which we're going to do right now. So my goal for this, and I apologize because we are short on time, so I am moving kind of quickly, but it's being recorded and I will be in the Q&A. I want to give you guys a crash course and also some tips and tricks to help you maybe with any obstacles that I've seen consistently customers running into as they're trying to build and develop these things. So step zero of any automation is, what do I want to automate, right? In this example I'm going to do, I want to automate switch configuration. So the workflow that I like to go through typically, rather than just leaping right into a playbook where a lot of things can go wrong, I want to kind of piecemeal together the building blocks of what makes a playbook work, so I can kind of build confidence along the way that I'm following the kind of right procedure. And the first place I always start, especially for something that's API driven, is the API documentation. So I'm out here at developer.cisco.com. I'm looking at the Meraki API documentation for updating switch ports. And here we can see a couple of very important things, namely, what are the required variables that I absolutely have to have no matter what, which in this case, it's the serial of the device and the port ID that I want to configure. And then below this, we can see all of the configuration options for that interface. VLANs, access policies, STP config, all that stuff. And this will help you kind of understand like what it is and how those things map to what you might configure in the GUI, right? Now, after I've found the API I want to use, I've understood kind of what it's expecting, I want to actually, again, before I leap into Ansible, I want to go try that API out. So in the bottom of our nav bar here, you can see we link to a Postman collection. Postman's a great tool for just experimenting with an API, for testing, what kind of data am I getting back? What kind of data is it expecting for me to send it? So this is kind of a confirmation step that I always like to go through when I'm building an API-driven playbook. So I'm just going to hit this get device switch ports API. And here now I can see all of the switch configuration values for this switch that I'm looking at here. And if we go over to dashboard and look at that switch, oh, wrong browser window. We're in the Craig SpokeNet network here, and we're looking at this switch right here. Here we go. So all of the stuff that we see in the dashboard GUI here for that switch port information, all of those things are represented as JSON key value pairs here. So here you can kind of get an idea of what data you want to capture, what data is important for you for your config that we're going to need later in Ansible. And I'll show you guys that in a second. The other thing that's really handy with Ansible is because it is built off of the Open API spec, again, foundational, all of these names, and they are case sensitive, all of these names will be the same in Ansible as they are in Postman. So a lot of times you can lift your configuration right out of Postman, translate that JSON into YAML, and it'll behave the same. So the next thing I want to test is just updating an actual port configuration with the API. So here I've created just a little snippet of what I want to configure for a single interface. Again, the small building blocks, don't eat the whole elephant, piecemeal a little small at a time to build that confidence along the way. So we're going to configure this single interface here on that switch port. And I just called the name of that interface for this demo Postman test. So if I flip back to dashboard here, this port was called uplink trunk. I'm going to refresh this page and we should see that interface name has changed. And now it is called Postman test. And I can see in Postman, yes, I got back a 200 okay. I've successfully configured that interface. All right, so now at this stage, I'm ready to actually get into Ansible. And the way I like to do things in Ansible, I take an opinionated approach. With all things automation, there's definitely more than one way to skin the cat. There's definitely different approaches that can be successful. This is my opinion, but how I like to structure things, I like to attach all of my config data into my inventory group vars and host vars. So the way Ansible works, you have an inventory that you build, and that inventory is hierarchical. It can contain one or many groups and subgroups, and you can attach config data either at the device, the individual host level, or the group level. And Ansible will inherit from groups all the way down the hierarchy to individual devices that are part of those groups. And devices can be part of multiple groups as well. So you can see here in this example, I have my Meraki network, and it contains MXs and APs and MGs and switches. But then I also have that same switch in a group called switches. And that way I can kind of control where I want to attach my config data, because it might not make sense for me to build a bunch of switch configuration and put it in this group that contains things that are not switches, right? There's also a special group called all, and that's where I like to stick things that are going to be consistent across all Meraki API calls. Stuff like my Meraki API key, which I've hidden here behind an environment variable, an org name, an org ID. You know, I have suppressed logging as true because I don't need a bunch of log data. If you're troubleshooting, you might want to turn that off so you get logs. This kind of stuff I like to stick at the all level. And then down at the group level, again, here's a simple example of switch port configuration. You know, here we can apply configuration, and any switch that is in that group is going to inherit that config. Here is how you get configuration consistency at scale, by leveraging this group concept within Ansible. So anything I attach to that group is going to inherit this config. There's also a concept in Ansible of variable precedence. So you can override those values by providing a more specific key at a deeper level in the hierarchy or a specific host itself. So you still have a ton of flexibility, because, you know, in a perfect world, you know, we all have exactly the same kind of config everywhere across our entire enterprise. We know that's not the case though. There's always snowflakes, there's always exceptions. You know, Ansible can allow for that by letting you kind of tweak that variable precedence and how you want those variables to be inherited across your environment. So in this example, again, trying to keep it really simple here, I show a few different interfaces. We're going to configure 3 interfaces. One's going to be a really simple trunk, you know, with a default native VLAN. One's going to be an access port. We're going to set up a voice VLAN. We're going to set up BPDU guard. We're going to attach a .1x policy to that interface. And then, you know, here's another example of a different way to do a trunk port with a different native VLAN with a different set of allowed VLANs. So we're still not ready for the playbook yet. I know it seems like that we should be, but the next thing I want to confirm for myself is that the inventory is parsing this data correctly, that my inheritance is working, that my inventory file itself is being parsed correctly. This is another stumbling point that I see a lot of people run into. They go to run a play, they know their API is working, they run their playbook, and all of a sudden, like, the device isn't configured the way they expected it to be, or it didn't get configured at all. Those problems a lot of times come down to some sort of syntactical error in your inventory. YAML is very white space sensitive. So if you have an indentation wrong, it can throw your whole inventory out of whack. And the way I test this, Ansible, built into Ansible. So here on my terminal, and I can make this a little bigger for you guys. I'm in a Python environment. I have my Ansible libraries installed, and there's a handy command called Ansible inventory where you can actually test that your inventory is being parsed by Ansible correctly. So I'm going to run this Ansible inventory command against my demo inventory here, and I'm going to give it a parameter called graph. And what that will do is it'll actually parse through that host file and say, hey, here are the groups you have, here are the devices in these groups. Is this looking like what you would expect it? So for me, this is giving me confirmation, yes, this structure looks correct. The next thing I want to test is that my target device that I'm testing against right now is inheriting all of that variable data correctly. So I'm going to run this command again against a host. And here we can see, using that variable inheritance, this individual host in my inventory, Craig Spoke Switch 1, it has got the API information from my all group. It has got the switch port information from that switches group, but it's also got the individual serial number that it needs. And I've attached that at the individual host level. So you can see at runtime, Ansible will take all these variables that can be spread around all these different groups and host places and kind of concatenate them and combine them into what you're ultimately going to run. So if you're having trouble troubleshooting your variable inheritance, this is a really handy command to see, what Ansible is actually doing with that data. Okay. We've looked at the documentation. We've tested our API. We've double checked our inventory. We're finally ready to jump into the actual playbook itself. And here I wanted to give you guys a bunch of tips of things that I've run into that I had to figure out myself by just Googling and looking at Stack Overflow posts. Basically stumbling blocks that you guys might run into. So starting at the top, we have our playbook name, and here is something I see a lot. A lot of people, when they write a playbook and they're testing playbooks, they are constantly changing what they're targeting. Again, the beauty of Ansible is you can change the scope of what you're targeting, whenever you want. If I want to target all switches, a subset of switches, a group of switches, a single switch, it's very, very flexible. What I like to do is variabilize, again, this double curly syntax is a Jinja variable. I variabilize that host value. So that way I can supply at runtime exactly what I want to scope, whether it's alls, whether it's one, whether it's a subset. And this becomes really, really handy. And we'll see this later when Daphne gets into her presentation too, of when you want to operationalize this, you're going to probably put this code into a Git repo of some kind. You don't want to be constantly modifying your playbooks. That invites room for error. Things can go wrong. So rather than having every time I want to rerun this, having to go change this value, change what I'm targeting for this playbook, I'll variabilize it and I'll pass it in at runtime. That's hot tip number one. Tip number two, something that you might not see commonly in Ansible playbooks is this serial command. So what is this doing? So as we've talked about, Ansible under the hood is using our Python SDK to make API calls to dashboard. If you're using the native Python SDK directly, built into that SDK, we have the ability to gracefully handle rate limiting. So if you are hitting the API really hard and you get a 429 rate limit, the Python SDK will put in a sleep, it'll back off, and then it'll retry that after a pause period. Ansible doesn't behave that way when it sees a 400. When it sees a 400, Ansible goes, that's an error. I need to stop what I'm doing. I'm going to pause execution. So you have to be really, really cognizant as you're designing these playbooks about the Meraki API rate limit, which is 10 calls per second. And if I just let Ansible go full blast, this thing will blow the rate limit out of the water, especially for something like switch port configuration, because switch port configuration is really API intensive. It's an API call per interface. So think about if you have a 48 port switch, well, now I have a stack of 3 of those, and I have those across hundreds of sites. It ends up being thousands of API calls, which Ansible can do really, really, really rapidly. So we kind of want to artificially throttle how many API calls it's making. By leveraging this serial command, I can have Ansible only target one host at a time for that. So typically, it can fork and do 10 simultaneously. It's just too much for the API. So I like to throttle it. If you don't do this, you'll end up getting into a situation where I've seen this with so many customers. They're doing what I've done. They're testing with a single switch, and it worked. And then now they go to deploy to prod across 1,000 switches, and all of a sudden they're getting error. It's from the rate limit. So something to be cognizant about. The next kind of trick I like to use is this syntax right here, which is a Jinja filter within Ansible. This default omit, what is this doing? So again, I want to keep my code dry. Dry in programming means don't repeat yourself. So here I have situations where I have a trunk port and it has native VLANs and allowed VLANs, and then I have an access port and it has .1x policies and voice VLANs, and there's configuration items that exist between the two of them that are mutually exclusive. So rather than create one play just for trunk ports and a different play just for access ports, I can actually combine them into a single play. And then if this data is not defined, for example, for a trunk port, I would not have a voice VLAN defined. If that data is not defined, I'll just skip it. And that way, Ansible will create that parameter when it sends that API call, and you won't get an error back from the API. So this is a really, really handy trick to make your playbooks really highly reusable. I use it all the time, especially in wireless config, because your wireless SSIDs can be wildly different, between different SSIDs. So moving down this list, again, you'll notice all of these parameters match the API documentation exactly. So if I were to go look at that API documentation, let's bring up the right browser window again. You'll notice that it is the same in Ansible. So a lot of times I'll just reference the API documentation. The other thing to reference though is the documentation up on Ansible Galaxy. So if I'm on Ansible Galaxy, that's where I'm getting all of these collections from. And you can see for Cisco, we have a lot. We have basically our entire portfolio. We have some kind of Ansible integration with. Looking at the Meraki one specifically, first thing I have to figure out is what module do I want to use? So how did I derive this device switch ports module? Well, I got that from the API path itself. So if I look at this API path and I remove this variable from it, it's device switch ports. So that is what matches the module name over here. And again, looking at this module documentation, you'll notice because everything is built off the same OpenAPI spec, all of these parameters are the same. So I'm not just making these up out of my head, I'm getting these out of the API documentation. So back to our playbook, we've got our module, device switch ports. We've got all of our parameters that we want to send. The next thing I have here is a loop. And the reason I loop here, and this is another thing that confuses people, Ansible automatically loops through this list of targets. So if you give this a group and there are multiple targets in it, it will implicitly loop through each of those targets. So that's automatically happening. I don't have to tell it to loop, it does it by itself. But for this particular API call, I want to make it across all switch ports on that target. So for that, I need to define a loop here. And the thing I'm going to loop through is this list of switch ports. And again, that list is defined here in YAML. This hyphen denotes a list item in YAML. So I've said, hey, go get the value of this variable. It's called switch ports. It is a list. Loop through each item in that list and go and configure these parameters. Just to be extra careful of the API rate limit, I've also put in a pause here. And just in case there was some misconfiguration, and let's say I did a target all, and all includes APs and MXs and things I don't want to configure, I put in a condition here to say, hey, only do this if the device in the target list is in the switches group. So that is how the playbook is put together. Let's run it. We'll pray to the demo gods here. And I'm going to run my playbook for configuring switch ports. It's going to go through that list of 3 ports. Ansible has noticed because Ansible is what we call idempotent. It will do a get first and determine if it needs to make a change or not. If it doesn't need to make a change, it won't. If we remember, when I configured port 1 earlier in Postman, I had changed the name to Postman test. So now I've enforced, my config standard by running this Ansible playbook. The name of that interface is supposed to be uplink-trunk. And if we go back to Meraki dashboard and we look at our interface config, we should see that name change back to uplink trunk. Okay. I know that was a lot to take in. I know I talked really, really, really quickly. I'm going to be in the Q&A for like the next 30 minutes. We have a ton of great resources on developer.cisco.com. So there's learning labs, there's Ansible examples, there's code. I have my code repo, which we can share out at the end of this call. But yeah, watch the recording, use developer.cisco.com, take it all in. And the last kind of hurdle that I want to leave you with to segue to Daphne is, the keen-eyed among you might have observed, I've been doing all this just locally on my laptop. One of the challenges of scaling to infrastructure automation is we need to be able to do this at an enterprise level with not just one guy writing code on his laptop. We need code to run in Git. We need code to be shareable. We need to be able to collaborate. We need to build workflows with dependencies. A lot of those kind of enterprise challenges are solved using Ansible Automation Platform, which Daphne is going to talk about next. So I'll hand it off to Daphne.
Thank you. That was really insightful. I wish I had a trainer like you like a few years
I
ago.
learned the hard way, Daphne. I went to the school of hard knocks.
Like we all do. It was the same. Like first time I struggled figuring out, is this the right screen? No. What I'm sharing the what is Red Hat Ansible Automation Platform?
No, you're sharing notes right now.
Oh, okay. So I'm sharing all my links. Just a second. Wrong tab. So I was sharing, okay, screen 2. Finally. I'm happy that was not the passwords one. Okay, cool. So what's Red Hat Ansible Automation Platform? So as you said, the challenge here is how do we move that to production with all the standards that are required for our companies? And also, how do we share and collaborate the code? I think the premise here on having Red Hat as an open source company is also the collaboration approach. You show the Cisco ecosystem that applies also to other technologies like virtualization, Linux servers, Windows servers. So at the end, we cover all these with the same platform, with the same language, with the same technology, and with this modular architecture. I love to think about the Lego analogy as the building bricks for Ansible automation. Helps you to connect or to extend use cases with other teams. Some of the use cases we had from our customers as success stories, for example, were triage use cases. When the issues outgrow the networking team and when you need to collaborate or to gather information for an end-to-end stack, so you know actually where is the root cause. Now, the platform itself, we have this subscription model, but the platform itself, you probably heard about Tower. That's now automation controller. So the platform has all this tooling that's needed to create automation content. That includes Ansible tools. To manage it, that includes controller, and to scale, event-driven Ansible in this case. Plus automation mesh and other technologies to have distributed execution. How does it look like? That's why I was sharing my screen. Is now we have this unified UI. So this is what was Tower, which is the automation controller. And if you see here, you can manage all these inventories and everything that Jeff explained, but shared and enterprise-based. So think about having this grouped or this hierarchy that we have to address for different inventories, teams, and user access. All of that can be managed here, and you can attach your hosts. Now, this is an empty one, so that's why we have little technologies, but the one I'm going to use is this Meraki Dunder Mifflin for this demo purpose. Second thing I wanted to share, and you probably saw my notes, was also the host and groups and the access management. The other thing where I see everyone struggles is on versioning of and ownership and the control change of what are the different versions when I'm playing with automation, right? So here we also have the access management. That's basically the organization's teams, user, and roles, like who does what, who can execute with set of actions with all the customizations that are required, so automation can be run or can be created by specific individuals or teams. That helps also with the governance of the automation itself. Okay, now I'm going to mention automation mesh. Reality is Meraki might be one of the most simple technologies to manage networking. Unfortunately, it's not everywhere. So you also have this combination of legacy devices that while you want to migrate or standalone devices, that you still need to integrate. So in this case, we have what we call automation mesh. It's basically the ability to distribute control and execution. So you can have distributed execution, but at the same time, you have decentralized control. This is how a branch looks like for us. So you have this box, you will have your Meraki dashboard controller, and you'll have all these multiple technologies that you have to deploy, check for compliance, audit, and remediate at scale. The other thing I want to emphasize here is also that you have enterprise systems like ITSMs, like ServiceNow, observability solutions like Splunk. So Ansible Automation Platform behaves as this glue where you can integrate all these technologies in a single place. So when I'm thinking always about network automation, is also on the end-to-end flow. Like what happens during an incident, you might need to open a ticket, communicate to a WebEx chat, notify to specific people. So you have a workflow that you have to solve. And the demo I'm going to show now is a workflow. It's a very simple one, but we have seen more and more even nested workflows for some of these triage use cases that I just mentioned. So one of the use cases we had that was a few years ago, I think some industries are still moving or relocating remote sites, is the site expansion. I've seen that a lot with Meraki and retailers, mostly. Some pharmacies, some branches, supermarket or restaurant chains. So basically, how do I deploy a new site consistently? And how do I manage the data operations next? So that's basically a use case I'm going to show. And secondly is the configuration at scale. That's basically how do I remediate or how do I provision new policies? For example, in the firewalls, the landscape is always changing. So I might need to deploy a new configuration policy immediately, or a new configuration change immediately, and I have to do that at scale. So that's the configuration at scale use case. And let's go and see here. Oh, something I also wanted to show, sorry, was how we link with GitHub. So this is my Dunder Mifflin project. As you might see, I love the office. This is my source control. This is where I have all my playbooks. This is public, so I can share it with you. I've been playing a lot here on the playbooks, but also the collections that were shared by Craig also have some of the playbooks. I want to show something else. With the subscription, you have supported collections. Sometimes the latest and greatest is not the most stable, so you will have some differences between the versions that are in Galaxy or in what we call Automation Hub. Automation Hub is in console.redhat.com. It comes with your subscriptions, but also you can have a private instance here to host your own versions or to host your own collections on-prem or in your cloud Ansible automation platforms. Okay, so this is my project. This is how I linked here in the project. So I have some source control. And I have all this versioning on what's changing with the projects. Once I sync, and if you see here, sorry, these projects were synced. So I can sync any project, and I will be pulling the latest playbooks. Now, how I'm linking or how I'm executing, you can do that in pieces and then you can nest. Think again on the Lego example. Here I built, for example, a get organization ID playbook, one to create networks and one to configure the firewall policies. I can run them individually or I can run them as a flow. So once I build my job templates, I can create a workflow. That's basically the logic. So here, this get organization ID, that's a read-only one. I love read-only use cases because they help you prove value without risk. And I've been a network admin. I've been a former Cisco employee. I know what could be the blast once you fat finger something that you shouldn't, because I did that. So this is a playbook I have, for example, that's just running. So things I want to show here. How we are executing lately, we added a new, we added containers basically for the execution. Why? Because it makes simpler to move dependencies from development to production. Second, the platform itself will show you the execution and you can change the verbosity, but moreover, you have now an audit trail. So if someone else is running it, I'll see in the job what was run, who ran it. I'm using a different user. That's Aubrey Strotter from technical marketing. What was the inventory, when was it run, and when it finished. So basically here you have your audit trail on what changed. And I think that's foundational when you are sharing ownership with other members from your group. Second that I wanted to share was also this execution environments. Remember I mentioned the container images. So I have this Meraki execution environment. It helps also to control like what I want to automate. Some customers have giant network execution environments. Some will have like more modularity that depends on how you define your architecture to execute the automation. And let me go back to the jobs. Something else I wanted to share, going with how we address variables before I run, was easy firewall policy. Greg, you mentioned the variables. So here we have, oh, sorry, I'm checking the execution. I'm going to go templates, firewall policy. We have surveys. That's basically the ability to ask for input variables. And here, this is my variable name. I'm defining what's going to be the default answer. I can modify it. It's going to ask me for an answer. But that's basically what I can do to survey or to prompt for the execution. Same here. This is a testing network I have built for Cisco Live. We had workshops. In the case of automation, and same with API, knowing your organization ID and your network ID will be relevant. And here, this is my variable name. Now, I could run the automation by itself, and I'm running just one task as I did with get.org, or I can run a workflow. In this case, I built two tasks, one to create a network, one to create a policy, and I built with that a workflow. So let me show you the visualizer. I know it's, sorry, I'm zooming the wrong way. Okay, so what's going to be doing that flow? Basically start, I can define the behavior like run always. I can define the conditions. So I'll start getting the organization ID just to check if I have connectivity. If that works, it means I can create the network. So I chose that it's going to run on success. If this dependency works, if this task works, then I go to the next one, that's create a network. If the network creation works, I'm going to ask a manual approval. I just added this for DevOps purposes, and I added a very short time, that's 30 seconds. If I reject this approval, then I don't configure the firewall policy. That's kind of like the logic here. If I approve it, then I'll configure the firewall policy. So I will launch the workflow so you see how it looks like. Then I can remove the approval as well. we have a visual tooling for it. You see it's running. And then I will get the ask. So here I can approve or reject. I'm going to approve. You see it expires in 22 seconds. I feel like that's a ticking bomb. Okay, so it should be running. You see it's moving forward. So what's happening in the background is here. I have now created a new network. And that new network has the standards I defined in a playbook that exists in that GitHub repo. My playbook is not very intelligent, but I will show you what I'm doing there. That's the webinar September, and I'm basically configuring some basic SSIDs with the name of the network as the webinar September with the specific settings. And I'm configuring also the firewall policies. That's the last step that I was running. So the firewall policy, I just added one to deny this traffic. Now, what happens if I remove the traffic, which will happen at some point? I came with the theory that drift is unintentional. We don't really intend to create drift, but things happen, we have issues, you have to troubleshoot. At some point you will remove some rule, and sometimes you will forget. Now, what happens when you have these drift situations? You can always remediate. Here I'm not launching the workflow, I'm just running the policy. Now, this is kind of like hard-coded, but you can go with a level of sophistication that's very interesting. Okay, so I'm basically updating the rules. So that's the rule I'm applying. And second thing I wanted to show before let me prove that this worked, and then I'll go to the verbosity levels. Okay, then I reinstated the rule. So that can be applied at different levels. It can be for everything. Probably you have some specific applications that you want to deny everywhere. Some per region, some per country. We have seen some differences in governance and variations depending on country regulations, for example. So that applies for global organizations. Now, something else I wanted to show before I forget is and giving you enough time also to have some Q&A, is the verbosity level. Sorry, I'm going to edit. When you're troubleshooting or when you're creating, sometimes you will want more verbosity. So right now it's normal. We can run debug and we'll see what it's doing in the background. So you have you can change your execution environment if you want to try a new container version with a new image with latest dependencies. That's how I'm linking the credentials. For example, here, this Meraki Cisco Live US is the API that I'm using to send to communicate to Meraki. So you can also define like different levels of execution. But if I rerun this job, it will go with more verbosity. So that's something that's also helpful when you are troubleshooting in Ansible Automation Platform. So you see, it's going very detailed on the logs. So it's basically showing you exactly what it's doing. Now, what I did or where it was, that's in my playbooks. So I have this create branch, the one I used. I can always see here, sorry. Templates, I used create network, sorry. So that was create network. So this is the playbook. You see, I was just invoking a key, the organization ID that I put in the survey, the network name that I put in the survey. And I'm asking to create this switch wireless appliance. And the other playbook for the firewall policies, I think it was this one, or configure firewall. So you basically are using these modules to here read the organization's filter which are the appliances, and then update the allowed IPs. Now you see here I have very specific or hardened IP address. You can always call to other variable files and add more complexity to it. So some that's in development, for example, is this one. I expect to have a nicer and more advanced demo soon. That's technical marketing in the works, but that's what I wanted to show. Okay, let me go back to the slides so we can give you time. This is what I did. I skipped some slides. Provision the network, configure the switches, configure the access point settings, and configure the firewalls. All of that can be done at once with an audit trail. And with that, Jeff, I'll give you the mic.
Awesome. Thank you so much, Daphne. That was awesome. Craig, that was awesome. That was very nutrient dense. And so I'm sure we're going to have a lot of people viewing the recording of this. And then a reminder, reach out to your Cisco account teams, to your Red Hat account teams, and let's stay engaged on this. Craig, Daphne are both amazing resources, and they work for amazing companies with lots of great, programmability, experience. So again, stay engaged, with the automation team here. The next thing is marketplace. Definitely get on this the marketplace. From the marketplace, the Cisco marketplace, you can actually engage Red Hat directly from there as well. There is a link. Again, we will share this link. We'll share these slides, and that link will be in there. The next call to action. This is a monthly webinar series, and so use that QR code and you can see all of the events that we have upcoming. Next month, I believe we have a very security focused, and we're going to be talking about secure access and cloud security on-ramps. Sign up and stay engaged after this. If y'all have any questions in the Q&A, Daphne and Craig are in there now as well. And I do want to make sure we also do some other plugs. So I'm going to steal the ball away here. And we'll go into slideshow mode. And then some other things as well is this is a great virtual event. Y'all, some of y'all join us monthly, but we do have some great next gen network experience roadshow events that were just put on the calendar recently. So we're coming to cities near you. And this is not just for the Americas. We actually do have an event in Buenos Aires as well. And again, this link will be included in the slides, but join us in person for our Next Gen Network Experience Roadshow that we will be kicking off over the next, over the next few months here. All right, so everyone that is stuck around from the beginning to the end here, we're gonna have a bit of a quiz show. And so first, we're gonna have 3 questions. They're gonna populate on the right side of the screen here. So everyone's gonna see them at the same time. Please post a single response with all 3 answers to the chat space. You can do it publicly, you can do it privately. We're gonna look at the answers and timestamp them, and then we will reach back out to the winners. Again, we're going to be giving away some gift certificates actually to the Cisco store, so you can rock some awesome Cisco merchandise, as a takeaway from this event. All right, so I'm going to put these questions up on the screen. I'll give everyone a few minutes to answer them. Once we get some answers on the board, we can review them, and then we're going to wrap this session up. So without further ado, our quiz show. So the first question, y'all can read them, but I'll read them out loud as well because it might be story time here. So what do the C's and CI/CD stand for? So we know the I is integration and the D is delivery. What do the C's stand for? The next one is, what is the HTTP error code for too many requests? I know Craig talks about this and the importance of leaving some backoffs in your code, especially when you're provisioning tens of thousands of switch ports. Ansible Automation Platform is a very powerful tool, but the Meraki Dashboard API is limited to 10 requests per second. And then the last one, an Ansible blank contains a role, playbook, play, task, and module. I see a lot of correct answers coming in here. So let's make sure we get all 3 with your name on it. And then we will be reaching out to you after this webinar ends to get you your Cisco Store gift card. Awesome. Yeah, and I think we pretty much have some unanimous consensus here. The C is for continuous, and you cannot do continuous integration and continuous delivery unless you're using an API and we're using automation. So, for today, for deploying our networks and keeping up to date with them, CI/CD is really important. Tomorrow, as we have more agentic AI that's monitoring our networks in real time and doing more self-healing operations, this API is going to be more important than ever. The 429, that is the request code. Craig mentioned that one. We want to avoid 429s, in the Meraki dashboard because there is a backoff at that time. And so again, writing efficient code, not going over that rate limit is critical. Then the last one is, the Ansible collection. And the collection is the all-encompassing kind of a folder that contains your role, playbook, play, task, and modules. And so that was a lot of fun, everybody. Daphne, Craig, thank you both so much for joining us. We'll be reaching out to the winners of the quiz here after this event. And again, we are going to be sending out a copy of this recording to everyone that attends. And so please go back. There was a lot of information in here. And if we do have further follow-ups, do not hesitate to reach out to your Cisco and Red Hat account teams. We're here to help. We're here to help you automate, and we're here to help you succeed in your network transformations. So I hope this takes us one step further on our API journey. Like if you started here and you were API aware, maybe you're a little bit more API ready today. And if you were API ready when you joined this webinar, maybe we have some confidence now to start going API first with our deployments. And that's really the journey that I think all of us need to go on. And just let's use this knowledge to take that next step in using programmability to deploy our IT infrastructure. Thank you all so much today. Daphne, Craig, thanks again. Thank you to all the attendees, and we will see you all next month on a next episode of Mastering Enterprise Networking. Cheers, everyone.